$783.28. When you look at the domain for an exponential function, the domain will always be all real numbers. On the range will be dependent upon where your asymptote is at. The asymptote for this is y is greater than, not equal to, because it never touches that x-axis, so it's greater than 0. So y is greater than 0. Looking now at problem number 2, it says that the most recent virus that is making people ill is a fast multiplying one. On the first day of the illness, only 2 virus bugs are present. So 2 is that initial amount. So the principal here is 2. Each day after, the amount of bugs triples. So if you triple the amount, that means the amount is increasing by a rate of 3. %. 300%. I'm sorry, that would be at a rate of 200%. It's 200% more than what it was in the beginning. So that would be a factor of 1 plus 2. So when you move the decimal point 2 places to the left, it gives you 2, so 1 plus 2. So your factor then would be 3. So you know that this is growth because it's increasing. So what you've got now, each day after the bugs triple, so that's 3 times the amount, and it says to write a function that models that growth over time. So the function then is going to be y equals 2 times 3 raised to the power of x. So it started out at 2. The first day that it had a chance to triple, that made it 6. The second day, it went to 18. The third day, then, it went to 54. The fourth day, it went to 162. Then on day 5, it jumped to 486. So from the start of it with 2 bugs found until day 5, there were an additional 484 bugs. So it jumped from 2 when it was first detected all the way to 486. So again, on your exponential function, your domain is always all reals. Your range here is y is greater than 0. On problem number 3, you have a bad cough and have to attend your little sister's choir concert. You take cough drops that contain 100 milligrams of menthol in each drop. Every minute, the amount of menthol in the body is cut in half. Use X for minutes, Y for the amount of menthol in milligrams remaining in your body over time. It is safe to take a new cough drop after the level of menthol in your body is less than 5 milligrams. How long will it be before you can take another cough drop? Now, our initial amount is 100 milligrams. Now, it decays, because it's going down, it decays at a rate, it says that it cuts it every minute, the amount of menthol in your body is cut in half, so the rate of decay is 50%. So that's a factor. Then if you take the rate at 50%, remember if it's decay, it's 1 minus the rate, which in this case is 0.5. That's the same as 50%, or 1/2. So 1 minus 0.5 is equal to 0.5. So your factor then is 0.5 or 0.5. Your equation would look like this then. Y is equal to 100 times 0.5 raised to the power of x. So the amount of menthol in the system when you begin is 100 milligrams. So if it decays at a rate of 50% per minute, then after the first minute, there's going to be 50 milligrams left. After the second minute, there are going to be 25 milligrams left. After the third minute, then there are 12.5 or 12.5 milligrams left. After the fourth minute, there are 6.25 or 6.25 milligrams left. At 5 minutes, there are 3.125 milligrams left. And then at 6 minutes, there's 1.5625 milligrams remaining. So it says that it's safe to take another cough drop after the level of menthol in your body is less than 5 milligrams. So how long will it be before you can take another cough drop? Well, you can take another cough drop after it goes under 5 milligrams, which would be after 5 minutes. The domain, again, is all reals. And the range is y is greater than 0. On the last one, Ian's new Mercedes cost him $75,000. So that's your principal, $75,000. From the moment that he drives it off the lot, it will depreciate. That means it decays by 20%. 20% is your rate. Remember the percentage sign. Now it tells us to use X for the years, Y for the car's value in dollars. What will the car's value be at the end of 5 years? When you see the rate, again, it's depreciating. So notice to get the rate, to get the factor, it's 1 minus the rate, which if you move the decimal point from 20%, move it 2 places left, it's going to be 1 minus 0.2. So the factor then is going to be 0.8. Because you have 80% of the value of the car left each year. It depreciates by 20%. So each year 20% of the value of that car is reduced, or the car's value is reduced by that 20%. So there's 80% of the car's value that remains. So in the beginning, it starts at $75,000. So each year as it's reduced by 20%, that first year it goes from $75,000 down to $60,000. The second year it decreases to $48,000. The third year it decreases to $38,400. The fourth year it decreases to $30,720. And the fifth year it reduces in value to $24,576. Now we got those values by our equation y equals our initial amount, which was $75,000, times our factor, which is 0.8, raised to the power of x. If you put that in your y equals and then press second graph, you can go to the table and get these amounts out of your table, or you can replace the x in the exponent position with the number of years you want to find out as far as the value is concerned. And at the end of 5 years, that value has decreased all the way down to 24,576. So again, when we look at the graph, the domain is all real numbers. The y, or the range, is greater than 0.